Welcome to 1.2, Relations. Today we're going to talk about what a relation is, talk about horizontal and vertical lines, X and Y intercepts, and explore graphing on our calculators. So please get a calculator, or you can go to Desmos, desmos.com if you don't have one. A relation is simply a relationship between two variables, and a lot of times those variables are going to be X and Y. Your book describes a relation on page 20 as a set of points in the plane. Really, a set of points is just a relationship between X and Y or any two variables, so I like to define it as a relationship. And it doesn't necessarily have to be a function. That's just a specific type of relation, and we haven't covered that yet. So you can see that relation P is just these four coordinate points, and I've graphed it here. Relation S in example 2 is a bit more, I don't want to say specific, but it looks a little bit different. And we can graph this one as well. This one, unlike the first example, this one does not have a finite amount of points. It's actually going to have an infinite amount of points that satisfy S. For instance, one point that is a part of S would be 0, 2. Another point would be -1, 2. Basically, any x that's less than 1 and the y value being 2, those are all coordinate points that work in S, or that are elements of S. Even the coordinate point 0.7, 2, that would be something that works. So let's graph those few points that I said. I'll actually write those few points down. So these are just examples in S here, elements in S. And I think the first one I said was 0, 2. Then I said -1, 2, and then I even said 0.7, 2, just to show you that it can just be any rational number. It doesn't necessarily have to be an integer, like these two x values were. The only thing I can't do is 1 or greater, because that's not what we've said here in S. So let's graph those. 0, 2 is right here. -1, 2. And I said 0.72, which is pretty hard to graph, so I'm not going to get that specific. I can't get that close. But what I can do is realize that, hey, I have to be less than 1. So I can get really, really close to 1, but I can't quite hit it. So I'm going to put an open dot there, and I'm going to go infinitely left. This is all the x values less than 1, where the y value stays steady at 2. So this is actually a horizontal line, where y is 2, and it just has to begin here with an open circle, since we can't quite hit when x is 1, but we can hit everything to the left or less than it. Okay, next we're going to be exploring specific types of lines. These are specific types of relations. A horizontal line and a vertical line, I put them like this because horizontal is going across left to right, and vertical is going up and down. So that's the English part of this. Let's get into the math part with how to write these mathematically. A horizontal line is any line that is of the form y equals a number. Now, this is not the most mathematical way to write it. I'm using this. This is not a hashtag. This means number. So anything that's y equals a number, just like y equals 2 on the previous slide. A vertical line, and I'll keep it like this because it looks kind of fun. A vertical line is anything that is of the form x equals a number. That seems kind of backwards, right? Like our y-axis is the vertical axis and our x-axis is the horizontal one. Let's see why this is. Let's take a look at the example y equals -3. This is going to be a horizontal line since it's of the form y equals a number. That number is -3. What I'm first going to do is just make a t-chart or an xy chart just to plot some coordinate points. So remember, x is our independent variable and y is our dependent variable. Now, in this case, we don't have a ton of direction for x, like we don't see an x. Therefore, x can be whatever we want. So long as y equals -3, x can be anything. That's the only direction we have, is that y has to be -3. So, as long as y is -3, we're fine. I'll plot 4 points. And I'll plug in -1, I'll plug in 2, I'll plug in 3, and I'll even plug in -3, whatever. So long that y is -3, it is on this line. So let's plot those points. So I've plotted all 4 of those points, and then we can see that this actually forms a horizontal line through y equals -3. No matter what x is, that only takes us to the left and to the right, all these x values. We always had to go down 3 to get to y is -3. Therefore, y equals a number forms a horizontal line. Let's take a look at vertical lines. Vertical lines are of the form x equals a number. So the vertical line that I want to take a look at is the line x equals 1. This is a vertical line because it's of the form x equals a number. And we're going to do the same thing. And again, you don't have to actually do this t-chart every time. If you know what the graph looks like, go ahead and just plot it. I just want to show you why making a t-chart will work. So in this case, we're just told that x has to be 1. We're not given any instruction about y. So y can be whatever we want. So I'll plot 4 points again, and I'll do 0, 1, 2, 3, whatever. I'll just do those 4. And let's plot those 4 points and see that it'll form a vertical line. All right, those 4 points are plotted, and we can clearly see that that makes a vertical line through the coordinate, or through where x is 1. So every single coordinate point on this line has an x value of 1, and y can be whatever. Y could be 0.7, 0.2, negative trillion, it doesn't matter. This is the line x equals 1. Let's talk about slopes of each one of these lines real quick. So the slope of a horizontal line is 0. M is 0 of a horizontal line. And of a vertical line, the slope is actually undefined. I'm not going to put equals because it doesn't equal undefined. It is just undefined because there is no rise. Well, there's definitely a rise from point to point, but there's no run. So if slope is rise over run, we're rising an amount and then running 0. So we're doing a number divided by 0, which means the slope is undefined. For horizontal line, we do have a slope. The slope is 0. Now I want you to realize that even though the slope is 0 or the slope is undefined, that doesn't necessarily make a difference. The line still exists. Okay, so for example, in a vertical line, even though the slope is undefined, the line still exists. And in a horizontal line, even though the slope is 0, the line still exists. So just because the slope is undefined in a vertical line, that doesn't mean anything about the existence of that line. So these are examples of relations, horizontal and vertical lines. And one last thing I wanted to add about these is I wanted to show or write out something that I learned a few years ago from a student that I really liked. So horizontal lines, we can use the term hoy, and then for vertical lines, vux. And I just write it like that because it's horizontal and vertical. What this means is, and I'll just talk through it, h is horizontal. This means the slope is 0, and it's of the form y equals. So hoy, a horizontal line, has a 0 slope and is of the form y equals. Vux, a vertical line, has an undefined slope and is of the form x equals. So hoy vux is a little, what's it called? Not an acronym, maybe an acronym, I don't know. Just a little trick that you can use to help you remember horizontal and vertical lines. This year we're going to be doing a lot of graphing, and I know some of you in your intro videos told me that you're not a huge fan of graphing. I can't say that I was either in high school. I'm not sure what it is that makes students so averse to graphing, but I promise that you'll learn to either, if not like it, at least tolerate it and not think it's as bad, especially if you have your graphing calculator, which you definitely will need. So if you have your graphing calculator, we are going to get into the calculator on this example, but I want to first talk about the fundamental graphing principle, which I never heard it called this before, but your book calls it this. I just think it's a great name, but I don't think it's an official name. Anyway, so basically what I think it helps to know is that any point on your graph, right, whether your graph is a line, a parabola, a circle, some random graph of none of those, whatever it is, any xy coordinate point on that graph will satisfy the equation, meaning if you plugged in x and plugged in y into the equation, it would make it true. So let's take a look at this first example. I just made this up. This is a circle with a radius of that is the square root of 20. So, and it's centered at the origin. And you don't need to know that yet. We'll learn about that later this year. But this is a circle. And we want to know in part A, is the coordinate point 2, -4 on that circle? Is it actually on our graph? Well, let's see. If it is, that means if I plug in 2 for x and -4 for y, it should equal 20. It should make this true. So let's test it out and see. So if we plug in 2 for x and -4 for y, note my use of parentheses because it's negative, necessary, we'll have 4 and 16. Well, we can see that that works, right? 4 plus 16 equals 20. And I'm running out of room, and you don't really need this next step, but yeah, 20 equals 20, that works. So in this case, this coordinate point, xy, is on our circle because x and y satisfied that equation. Let's take a look at part B. This one's not going to work. We want to know the same thing, but in this case for the coordinate point -1, 3. Is -1, 3 on our circle here, on our graph? Well, let's plug in -1 for x and 3 for y, and see, I should put a question mark here because I don't know if it equals 20. And I'll get 1 and 9. And that definitely doesn't equal 20, right? So that just means that this coordinate point, -1, 3, is not on this graph. Let's put this into our calculator. The first thing that we need to do is realize that our calculator, it only lets us put y equals. So what we need to do is solve this for y to explore it on our calculator. So I'm going to do that over here real quick. And we'll have x squared plus y squared equals 20. And if we want to solve it for y, we'll have y squared equals 20 minus x squared. And then we need to take the square root. When we take the square root, we need to make sure we put the plus or minus in front. So plus or minus the square root of 20 minus x squared. Now, yes, this is a complex example, and I'm doing it because I think it's good to start with something more challenging. So let's put this into our calculator. We will have to put it in as two separate functions, one using the plus and one using the minus. Okay, this is the first time I did this on my calculator and just inserted the video. Hopefully I can find a better way to do this in the future, but for now, here we go. So we first go to the y equals button, and we want to plug in, again, we want to do both the positive square root and then the negative square root. So up in y sub 1, we'll do the square root key, second square root, 20 minus x squared, here's our x key. In y2, our negative symbol, same thing. Choose the square root, and then 20 minus, this is the key for x, x squared. Then we want to go to our window, and our window has min, max, and scale. Scale is how much each tick is worth. I picked -5 and 5 since I knew what it was going to look like. Once you hit graph, it will graph both for you, and it actually is color-coded if you have the 84. If not, it doesn't matter. But we can see that the positive and negative versions do make a circle. It looks elongated because it is a rectangle. When we go to table set, this is important, second window. You want to make sure your independent variable is on ask and your dependent's on auto. That means when you go back to your table by hitting second graph, you can plug in an x value. And I plugged in 2. Before we saw that when we plugged in 2, when x was 2, y was -4, and I know it's hard to see again, but we saw that the coordinate point 2, -4, worked and was on our circle, and in this case it was. So that's a really cool feature, is if you hit second window to go to table set your table, and make sure your independent variable is on ask. That just means you can ask your calculator whatever x value you want to plug in. When you go to second graph to select table, you'll see your table there. So you can plug in any independent variable, any x, and it'll output your y values, which is really cool. So that is just how we'll graph on the calculator. We definitely will do more examples of that in the future. Okay, our next topic is going to be intercepts. So in order to find the x-intercept, we let y be 0, and to find the y-intercept, we let x be 0. So you basically let the opposite variable equal 0. That's because the x-intercept is where the graph hits the x-axis, where y is always 0. And the y-intercept is where the graph hits the y-axis, where x is always 0. We're going to do this both algebraically and graphically again. So let's take a look at an example. This first example is a linear equation or a linear function, and this could also say f of x. I just wrote it as y. So if we want to find the intercepts, which we know there's going to be one of each since it's just a line, y equals mx plus b, we are going to just do this algebraically. So to find the x-intercept, we're going to let y equal 0. So we're going to have 0 equals 1/3 x minus 5. And then in order to solve, we'll add 5 to both sides. And to get rid of the 1/3 out in front, we'll multiply by 3 on both sides. So we'll have 15. And then 1/3 times 3 is just 1. That's why we did it, to just be left with x. So our x-intercept is 15. Now that means that the coordinate point 15, 0 is on this line, because when we let y be 0, x was 15. Therefore, the coordinate point 15, 0 is on this line. We know that this is on the x-axis if you plot it, right? It's our x-intercept. So you could say the x-intercept is 15. So I write that as x-int. This is one way that you could answer. This is an alternate way you can answer. So both of these are the same. To say that the x-intercept is 15 means the coordinate point 15, 0 is on our graph. All right, to find the y-intercept, we're going to let x be 0. This one's a little easier, so we'll have y equals 1/3 times 0 minus 5. So 1/3 times 0 is 0. 0 minus 5 is negative 5. So we could say that the y-intercept is negative 5. An alternate thing that we could say is because when we let x be 0, we found that y was negative 5. We know that the coordinate point 0, negative 5 is also on this line. You could also plot this on your calculator. I'm actually going to do one more example, and that's the one we'll take a look at on the calculator. Okay, our next example is a quadratic function or quadratic equation. This could also say y equals x squared minus 9. And since it's quadratic, we are potentially going to have up to 2 x-intercepts because it's a parabola and it could hit the x-axis up to 2 times. So we'll see that we find that in this when we find the x-intercept. So we'll first find the x-intercepts, which means that we have to let y be 0. So we're going to have 0 equals x squared minus 9. Again, because f of x is y, so we let this whole thing be 0. Now to solve this, you could factor it or you could just straight up solve it algebraically, which is what I'm going to do. So I'm going to add 9 to both sides. And then in order to solve for x from x squared, we do have to take the square root of both sides. And when we take the square root, remember, we do need a plus or minus in front because this is saying, what did we square to get 9? We could have squared 3 or negative 3. So we have 2 options here. So we actually have 2 x-intercepts. And they're the coordinate points 3, 0 and negative 3, 0. So this is one way you can write your answer. And then an alternate way that you could write it is that the x-intercepts are negative 3 and 3. Now don't put parentheses around this. This is not a coordinate point. I'm simply listing the 2 x-intercepts in a row. And this says int. I know it's a little bit sloppy, but int for intercept. So again, these are 2 separate ways to write the same answer, and I don't mind either way. Whatever way makes more sense to you. All right, let's find the y-intercept. And it's a parabola, so there's only going to be one y-intercept because the parabola is opening up. So it's only going to hit the y-axis one time. So to find the y-intercept, we're going to let x be 0. So I'm going to replace f of x with y, and I'm going to let x be 0. And so we're going to have y equals negative 9. That one's much easier. So again, this is the coordinate point when x was 0, y was negative 9. Or you can write it as the y-intercept is negative 9. These are 2 ways to write your answer. Let's take a look and see that we get the same thing using our calculator. Okay, so we plugged in x squared minus 9 and then hit graph. If you still had the same window settings, you can see that it's not going down far enough, so we're going to hit window. Window is like literally the window we can see. So what I want to do is make I did that wrong. The x doesn't matter, that's left and right. You can keep that at -5 and 5. Your y min, how low you see, needs to be down at least to -9. So I actually put -9. You could put -10 if you want, because it hits right at the bottom. So now we can see the important parts of our parabola. So we're going to hit second calc to find the zeros or the x-intercepts. It's going to ask us to left and right bound. Here's -3, here's 3. Your calculator is going to find it for you. Left bound, go left of it, hit enter. Right bound, go right of it, hit enter. Hit enter again. It tells you the 0. Let's go through that process again. Second, trace to hit calculate. Number 2, 0. Now we want to find this 0, this x-intercept. Zeros and x-intercept are the same. It's asking us to go to the left of it. Go to the left of it, hit enter. Now to the right, hit enter. Hit enter again, and it'll give you your second 0. -3 and 3. The trace feature is kind of nice, so you can also just hit trace and hit 0. So that last part was real quick, sorry about that. The last part was finding the y-intercept. So the y-intercept, an option that you can do since you want to let x be 0, what you need to do is just hit the trace key. The trace key will allow you to put in any x you want. So if you hit the trace key, and then if you just hit 0 and then enter, it'll show you when x is 0 that y was -9. So there's a few different ways to do this on your calculator. These are kind of the best ways, I think. So to find the x-intercept, you hit second trace, calculate, and then go down to where it says zeros, since x-intercepts are zeros. You left bound it, right bound it, and then your calculator will find it for you. The reason your calculator has you do left and right bound is because sometimes there's more than one x-intercept or 0, and your calculator doesn't know which one you want. So you have to bound it, go to the left and to the right of it so it knows which one you want. In order to find the y-intercept, you just let x be 0. So you can hit trace. That'll like trace anywhere you want on your function. And then if you just plug in 0 and hit enter, it'll show you what your y-intercept is.